We've got some familiar faces here, but I still want to go around the room real quick and basically just have you introduce yourself, what your role is, what you're looking to gain from the user group, and any questions you have that you'd like me to address throughout the session. Oh, and actually one quick thing. I'm also, and I'll remind again at the end of the session, I'm also gathering topics or questions for next month's session, which is going to be entirely like Q&A based or sort of like an office hour session. So feel free to shoot me a line on those questions as well. Okay, and with that, we'll go ahead and get started. So Barry, you're at the top of the list.
All right. Hey, great to see everybody. This is my first meeting. Databricks has been super hot for the last year or two, and I'm like, it's time to jump in and really understand how things tie together with respect to Power BI, the Power Platform, and how Databricks, is super important and really the go-to now moving forward. So I'm actually working on a project with you, of course, Spencer, right now. With Modern Workplace and data sources that we're using there are Databricks as well. So I just need to school up and understand how Databricks plays into my playground with respect to visualizations and the Power Platform stack.
Perfect. Well, this is going to be the first one where we have any Power BI on screen, so you picked the right one to start with. Okay. Hey, Ian.
Yeah, hi everybody. Yeah, just piggyback on Barry, just want to level up my skills, and Spencer's a genius, and just steal some of his knowledge to learn to do a bunch of new cool stuff.
Great, sounds good, Ian. And shout out to Lindsay. She's our moderator for today's session. So if you're having any connectivity issues, want to tell me that my mic's too loud, whatever, Lindsay can hook you up. And then Matt, I don't think I've seen you before, so welcome. I don't know if Matt's mute switch might be stuck. That happens to me sometimes.
Hey,
how about?
This is Puneet. I'm Matt's teammate, and we are from FedEx, and we both are attending this session for the first time, and our group has been trying to get familiarized with Power BI and Databricks and all the Power apps. So
awesome.
Looking forward to the session.
Awesome. Yeah. Well, thanks for coming. And yeah, definitely drop us a line, and we can have some conversations around your specific needs and what you're looking at. So that sounds great.
Sure.
Okay. Then Ruben.
Yes, hi. I thought I'd show my face.
Yeah.
I'm new to Valorem. Started on the 17th, so that's last week.
Yeah.
And I've joined because I was invited. No, not only. I am interested in Databricks. I have tried to get into it in the past, but always was pulled into work, into billable hours. But now that I'm waiting for the first project, I have some more time, and I hope to get started on this and other.
Well, love it. Yeah, happy to have you. Definitely appreciate the ambition, hopping right into some of our new technology stack. Awesome. And then Scott.
Hey everyone, Scott Davis, data scientist at Valorem. Even though I work with Databricks and Spencer, it's really hard to keep up. Databricks is doing so many great things. So I really appreciate Spencer putting in the extra time and hours just to keep us abreast of it. And for those of you that are new to Databricks, this is just like pure gold. So after working in Databricks and working on other things, Databricks really is so great and so useful. So I'm actually excited every time Spencer puts these on, even though we're constantly working together on projects. So keep it up, Spencer, and thank you so much for putting the time to do this.
Yeah, thanks for listening to yet another hour of me talking about Databricks. And then Sean.
Hi there, Sean Chartier. I'm a manager at Valorem Reply in the Modern Data Platform Group. Always interested in finding out what the latest and greatest is coming out of Bricks in the last week. Interested in hearing what the use cases are and how people anticipate these changes will be used. It's a constant activity to try and keep up not only with the technology, but the impact of the technology and the needs of the various users that plan on using it. So that's really why I'm listening in.
Awesome, great. Well, with that, we can go ahead and get started. So our deck today is going to be a little bit light on purpose. This is a pretty demo and code heavy topic. So we'll mostly be in the Databricks environment today. So let me get that pulled up so everyone should be able to see our slides. So like I said, this is the August Databricks user group. We'll focus specifically on the data lakehouse model today, but as always, our goal being partners with both Databricks and Microsoft is to accelerate insights for companies to try and improve their performance. I think that's why a lot of us are here. Databricks is definitely something that I would be interested in as a curiosity, you know, in a vacuum, but I think definitely its application to enterprise is what has all of our attention. So let's dive in. So the data lakehouse is something that we've talked about, I think, way back in like April or May in our first ever session. So you may recognize this slide. So this is coming straight from Databricks. It's essentially a diagram of the evolution of data architecture over the last 30 or 40 years. So really, data warehouses have some of the longest history of any piece of technology in applications of business intelligence and decision support. That's sort of like the advent of, you know, sort of the modern decision support line of business. And so since the 80s, data warehouse technology evolves. You know, we are able to handle more and more data sizes, but warehouses turn out to be really great for structured data, but they have a lot of trouble dealing with unstructured data. Notice down here, this is all coming from our more relational structured data sources, and we're just pumping them out into our data marts, right? And so in modern use cases, we have to deal with a lot of unstructured, semi-structured data that has high variety, velocity, volume, all your normal 4 Vs. And that comes from the advent of, you know, image data, video data, audio, log files, and then still dealing with some relational. And so since data warehouses aren't suited for some of those use cases, and they're not the most cost efficient, companies began to collect large amounts of data from different sources into data lakes. And a lot of that became possible due to the advent of massively distributed file systems like Google file system and Hadoop file system. And they're really great. They're cheap, they're highly efficient, really performant. They just can't do essentially the structured stuff as well as the warehouse, and the warehouse can't do the unstructured stuff as well. So we kind of need both. And so really having a data lake as a repository for data in this wide variety of formats made it suitable for storing data, but critically you can't access data as well. So they don't have great enforcement for data quality. They don't really support transactions that well. And having no consistency or isolation makes it so that it's pretty impossible to mix appends, reads, and do both batch and streaming jobs at the same time. And if you read some of the original white papers for like the Hadoop file system, for instance, or GFS, you'll see that a lot of the time and energy, the thought processing went into making it work at all in terms of having those concurrent appends and reads and how queuing system works, or the queuing systems work. And so it kind of makes sense that in its immediate advent, we're not going to be able to get all of the key transactional features of a warehouse. Like that takes sort of an evolution. And that's really what the Lakehouse is. So a data lakehouse is fundamentally just a new paradigm for data management that takes the best of data lakes and data warehouses. So you basically are solving the crucial features of each. So while they're suitable for storing data, data lakes aren't able to support transactions, all that other stuff, like I said. And so data lakes have become data swamps in many enterprise cases. And the promises of data lakes haven't really materialized in the way that many of us expected. And so that makes it so that you're gaining certain benefits, like being able to process these new types of data, but you lose the ability to have, for instance, data auditing and governance, that real-time transaction support, et cetera. And so if you look at this lakehouse model, you can see that essentially we're pushing down this ETL and data prep and validation onto the data lake. And so we have this decoupled compute and storage, and we'll get into that a little bit later, but essentially we have this entire processing layer that can then be used to process all types of data, whether it be structured, semi-structured, or unstructured. And ultimately, all of the BI or decision support work lanes can all work off of that same data storage environment. And so by implementing similar data structures and data management features from a data warehouse directly on low-cost storage, like on a data lake, then you get this single system that makes it so that your team can have much higher velocity. They're able to use data without working across multiple systems. You know, you don't have, and I probably should have included this slide, but we like to show this idea of these data silos that get created, where if you are on the marketing team, your single source of truth now is totally different than that of like the sales team or the accounting team. And fundamentally, you know, there's room for multiple lakehouses within a company, but in an ideal world, your analysts within a certain concern are all working from the same system to increase their velocity, lower the amount of just like, you know, throwing a bunch of data in a bag and throwing it over a brick wall to another team. And so data lakehouses essentially fix all these problems, make it so that you have up-to-date data available for your data science, ML, and business analytics workloads. So really, what does that mean? What does that allow us to do? So the combination of cheap high volume storage along with some analytic workloads, you know, makes sense in a vacuum. It's an idea that probably anyone could come up with, but the way that it was actually done, and there have been a couple of different ways of doing this, as we'll talk about towards the end. Databricks just happens to be one of the leaders in it. Same with Microsoft Synapse, but it's the result of implementing those warehouse design features and transaction features directly on a data lake store. And so this is facilitated by transaction support. So a data lakehouse allows ACID transactions essentially on top of a data lake storage. And that we'll look at in a later slide specifically what that means. But ACID transactions are crucial to all the SQL environments we work with, and it's a fundamental requirement of most workloads, especially at the enterprise level. Schema enforcement in government allows support for star and snowflake data models, your dimensional models, schema evolution and enforcement, and governance and auditing tools that allow you to emulate features that are consistent with a modern data warehouse. So again, all things that you would expect by default from something like Azure SQL Server or you know, Azure Synapse, or what used to be Azure Data Warehouse, I believe. And you know, all these things that we take for granted previously haven't worked on top of the cheap storage that's been offered by a lake. So having the best of both worlds is fantastic. As far as BI support goes, we'll look at this in the demo, but the data lakehouse can be directly queried by our BI tools like Power BI. I don't need to clone my data over into a structured environment or another environment that's like specifically designed for online transaction processing. You know, it's all available in the same space with no duplication, no overhead cost. Then we just talked about storage being decoupled from compute is crucial, not just for Lakehouses, but for Databricks in general. So even though we're using Azure Databricks, I could easily connect my environment to Google BigQuery or an Amazon S3 storage account. There's no dependency on which management system we're using and which storage system we're using, which is huge. That comes into play with the Lakehouse, because whatever paradigm our Lakehouse has can evolve and grow. And then let's say there's some new type of cloud-based object storage that comes along that just blows everyone's socks off. Well, you can immediately implement that as the storage mechanism for your data lake. You don't have to wait until Databricks decides to support it, or until whatever Lakehouse model of choice you're using goes ahead and implements that. And so that leads into our next point, which sort of got stuck between slides here. Openness. So having a storage format like Parquet, which is what Delta Lake uses, which is what we're talking about today, and having that storage easily accessible from things like SQL, R, Python, all of our normal tools, again, makes it so that you don't necessarily have to wait until your data lakehouse gets updated to support whatever new tool set is out there. If it supports R, Python, and SQL, you know, a lot of things could change and evolve and advance, and you're still going to be able to use that data as it sits at rest. And similarly, if a new data storage mechanism comes along and it still supports things like R, SQL, and Python, then you know that the Lakehouse of choice is going to be able to dynamically adapt and support that new type of storage. So both things are pretty huge here. And then we've already talked about ad nauseum, but support for unstructured through structured data. Being able to support diverse data sources, images, video, text, audio, that's the whole reason that we even need to have this discussion. If all data was super structured and clean, then we wouldn't need to have anything other than a data warehouse probably, and evolution of data warehouses would have gone in a totally different direction. It was the need to store these types of data that led to data lakes in the first place. Then we've also talked about the support for diverse workloads, so being able to do ML and data science, ELT, ETL, SQL, all on top of the same data store is huge, critical to the modern enterprise workflow. And having different environments set up for each of these cases is pretty common at a lot of companies. And so having a single source of truth is huge, but also a single piece of IT or technology. That means that you're spending less time on maintenance, spending less time debugging. If we fix a pipeline in one place, instead of having to go fix the same pipeline in 3 other places that 3 other groups are using, it's all available to the same teams and they can reap the benefits. And then finally, we'll look at this in the demo as well. But end-to-end streaming is baked into the infrastructure as an assumption. So we're not doing pseudo batch transactions where it's a stream, but underneath the covers it's really just quick batch or batch with some certain semantics that emulate streaming. Rich support for structured streaming is baked in from the ground up. We saw that a couple months ago in the user group session on structured streaming, and you'll see it come up again throughout the discussion on lakehouses, because it is a basic assumption of the paradigm. So let's talk about transaction support real quick. So ACID transactions, if you ever took a computer science database class, they probably hammered this into you, but atomicity guarantees that a transaction acts as a single unit. So it either fails or succeeds. There's no in-between nebulous state. So that makes it so that we don't have to do, rollback or, constantly guess like how much of a transaction succeeded. Similarly, consistency makes it so that a transaction can only take the database from one valid state to another. We're not going to get locked into a state where the transaction succeeded, but the database is no longer addressable. Again, I think we've all accidentally broken things in the past, so I don't necessarily want to even be able to do that as an admin on my data lakehouse. Isolation requires that transactions that are executed at the same time will be processed as if they were executed like in order and sequence. And then durability ensures that once a transaction is committed, it will remain so even if the database encounters a failure state. So all of these are critical for a lakehouse because they emulate expectations we have from a warehouse, but also because they're just fundamentally crucial for any highly concurrent workload. And especially with the dynamic nature of a data lake storage system, this becomes really big. So then with schema enforcement and governance, we can't audit unless we have those. And so for data infrastructure to be able to enforce schemas, but also support schema evolution is critical. So Delta Lake has rich support for these schema features through things like schema inference, the dataset API, and built-in schema evolution or automatic schema evolution. And so schema enforcement or schema validation is what allows you to prevent data from being written to a table if it doesn't conform to a particular schema. And so Delta Lake does this by using schema validation on write. So any new writes to a table are checked for compatibility with a target schema at write time. And if it's not compatible, Data Lake just cancels the transaction. No data is written, and then it throws an exception to the user so that you can, course correct. So if we want to figure out whether a write to a table is compatible, Delta Lake uses a couple of rules, and they follow below. So it can't contain any additional columns that aren't present in the target table schema. So it's okay for incoming data to not contain every column. Those columns are just assigned null values. And so this is kind of interesting. In practice, what this fundamentally means is you want to create a giant union of all possible schemas. So if you think about something like App Insights, for instance, where maybe you have several applications that all have similar but slightly different schemas in the sense that one page might track buttons clicked, but the other might not, and it might track something else. If you create a superset of those different schemas, all the things that are shared between them will be included. The things that aren't will just come through as null. And so in that case, you can enforce schema governance across semi-structured data in a pretty elegant way. So Delta Lake has some really nice paradigms for things like that. Similarly, you can't have column data types that differ from the existing column data types. Makes sense. But if something is named the same, but it's storing a string instead of an integer, then the schema enforcement will raise an exception and prevent the write from taking place. And then finally, it can't contain column names that differ only by case. So if you have capital foo and lowercase foo in the same table, even though Spark can be used in case insensitive mode, which is the default, Delta Lake is by default case preserving, but it's insensitive when storing the schema. That's because Parquet is case sensitive when it's storing and returning column information. And so in order to avoid potential pitfalls, data corruption, data loss, that kind of thing, they've added this as a restriction. So they're always looking out for us over there at Databricks. The last thing I want to talk about real quick, so we're going to move away from the slides. Let me pull it up. There's a couple of great resources out here. One second. From the Databricks blog. And one of them is a new Data Lakehouse paper that just got published. And I had the link in my browser closed, so I'm just digging back into my my history here. Anyway, you probably could find it, but essentially the white paper on the Data Lakehouse was finally published by the team over at Databricks that's led by their CTO, Matej. And it's a really nice explanation of essentially how they were able to do all this cool stuff on top of the data lake in terms of enforcing those ACID transactions, supporting structured streaming semantics, all that kind of stuff. And so it's a little bit dense. I think it's 14 pages long too. So I wouldn't necessarily like dive in expecting to understand every single bit, but even just reading those things and trying to think, you know, in reality, how this might work, you know, what questions you have about it. That's the kind of stuff that, you know, I'd love to talk about in a future, you know, user group session, and, you know, try and help each other dive into stuff like that. So anyway, that's that. There's also a really nice glossary that they provide. And so that's just under databricks.com/glossary. And you can essentially summarize the stuff that we've talked about in today's session. You can also hop over to, this is the article that really got me starting to think about the Data Lakehouse over on their blog from January. And you can see kind of a similar discussion here. But they dive into some examples from other companies that's kind of nice to see from Databricks. They're obviously, you know, some of the leaders in this new paradigm that's evolving and starting to, you know, dominate the marketplace. But they're, you know, calling out Azure Synapse as well. And they're talking about BigQuery and Redshift Spectrum and some of the limitations that they have or some of the things that they do better. So all good reading material. I'll include links to this stuff in the deck when we share it. But yeah, that is on Delta Lake. And then we talked about in our Spark Summit summary, but keep in mind how Delta Engine fits into this. And maybe this must have been the wrong link. Over in our Delta Engine deck, when we look at our Lakehouse model, essentially the Delta Engine sits right here between our workloads and our actual Lakehouse environment. And what Delta Engine is going to do is essentially accelerate all of those queries and transactions coming across on our lake. So it's just an engine for high performance query execution. So all of our SQL, data frame, even Koala's APIs are all going through a query optimizer, a native execution engine, and a new caching engine that can all deliver up to 20 times performance over the traditional Lakehouse as it sits right now. So that is not available yet. I think that's coming out later in the fall. But it's still something to keep an eye on. That's really what's going to make the Databricks Lakehouse sort of competitive with something like Azure Synapse. Because not only are we getting all the semantics of the Lakehouse, all the things that we talked about in the slides, but you know, at the end of the day, what we really care about is just blazing speed, and that's going to sort of tie all that together. So now let's jump over into Databricks. So this is the environment that I have been doing my Saturday streams in. If we hop over here, at the end of the day, it's really just doing one thing. So we have a nightly job that runs. If we hop over into this latest run, we can see it's really just doing one thing, which is there's a notebook I've created called Nightly Job. And within it, we're running 2 stages, a bronze and a silver. Now, if you remember from one of our initial presentations, the bronze, silver, gold, and platinum are essentially just different layers of data within our data lakehouse. And so bronze was previously called raw, silver was previously called the query zone or the structured zone, and then gold is our sanction zone. That's sort of where our single source of truth lies. And then you can think of platinum as like a self-service or KPI zone. That's one that not every project needs. It's kind of a nice to have, and it's beneficial, but it's not fundamentally crucial. So with that in mind, you can see that I've mostly been working on bronze and silver up to this point. Now, part of that is because I don't have a customer. And so I don't have an immediate need to go to gold. So what you might see in some cases is before silver and bronze are done being created or fully mapped out, you might go ahead and create some gold tables so that, for instance, like a set of Power BI consumers could start working with your data before it's like all just so. In my case, I focused extensively on the silver zone because that's really where our data warehouse lives. So let's jump in and see why that's the case. So if I go into stages, I'll go ahead and open bronze and silver. So what this is doing, so initially I'm just bringing in some parameters, doing some housekeeping stuff, grabbing a username for my API. And then down here is the cool stuff. So we're hitting an API for a tool called Untapped. It's essentially just like Foursquare, I guess, for beer. Essentially, you can just, track different things you drank or whatever, rate them, take pictures, that kind of thing. But I'm using it because it's one of the richest private data sets I have. And so what we're doing in this initial step is just sort of a sanity check. Can we access the API and confirming our total number of check-ins? Because down here, that sort of tells us how much we're going to try and pull in. So we're just looping over some API calls, truncating that all together into a giant JSON string. And that's really it. Now, that's sort of the boring housekeeping of like how we get our data. I'd be happy to talk about that more in person, or that could be, in private, not in person during the pandemic. But I'd be happy to talk about that more, especially like during next month's sort of open-ended user group. Well, what I want to focus on happens down here. So we're taking our JSON data and writing it out to our data lake. And so this untapped raw path is being pulled in up here as one of our parameters. And so essentially it's taking our base path, which is this, it's a mount path, and we're appending some basically file hierarchy to it. So we're making sure that it's under raw, under the untapped folder, and then, under raw, the untapped folder, and then we're injecting a date time using Python formatting, and then we're storing it in untapped.json. So basically the results for this API in a particular day are all sitting on our lake. And so it's called the raw zone for that reason, in that we have all of our raw data sitting at rest. So if in the future I totally change my mind on how I want to structure this, whatever, I can re-ingest it all totally from scratch. And I've actually done that. I think it was in this most recent episode. Let's look. I've had to, I think it was down here. Yeah, so you can see here, I actually looped through the entire lake again and brought it all back into a table and wrote that back out to the lake. And I was able to do that because it's sitting at rest in the raw zone. Now, for a particular day, what we do is once we write this data out to the raw zone as JSON, we read it back in as a data frame. That does a couple things. It infers the schema, makes sure that the JSON is parsable, make sure that there's data in there, sure enough. And then what we do is we write it out in the Delta Lake format. That's essentially, like we talked about a couple sessions ago, just a set of Parquet files with a transaction log. And feel free, if anyone wants to see this, you know, like in the data lake, if there's any questions, feel free to drop a line in the chat. But at a high level, we're just doing the Delta write mode, and then we're doing it in an append. So this table isn't just for like today's data, it's for all the data. And by appending it, we're not doing any integrity checks, we're not doing any deduplication, it's just going to be a giant Delta table. Now, eventually, maybe on like a quarterly basis, I might write a job to go in and clean and dedupe that. But for now, this is great. And we're saving it to the raw path underneath that Delta folder, as we discussed. So that's what's happening in our raw zone. Now, of more interest to us is this silver zone. So in here, similar housekeeping, we're bringing in some functions and parameters. This is being set to legacy mode for a particular timestamp function. I'll show you down below. We're doing our imports, verifying that our file paths all look good. So this is where the data lives. This is where the data will live as our root path for our query zone. And then we can see the first thing we do is we read in this raw data from the same Delta path that we had before. I'm setting the ignore changes option on so that it does not overwrite any existing data. It doesn't throw any hiccups with any existing data. We're focused entirely on new check-ins. Now, there is a difference here, read stream. So in bronze, and that you would have had to be pretty eagle-eyed, but in bronze, we're just doing a read. This is because in bronze, we're going straight from our data frame out to our lake. Here, we want to do a read stream because I want a streaming data frame, because this Lakehouse is end-to-end streaming. Now, even though this cluster, this Lakehouse isn't online all the time, it doesn't need to necessarily support some of those more robust features, like if you think about like an event hub or IoT hub where it needs to be always on. That's not what we're doing. Well, we're doing structured streaming because the semantics are so nice. We get so many things for free. So this is a streaming data frame. And then what I'm going to do is add, like I mentioned, some cleaned up timestamp information to it. So don't worry about this code. Just know that I'm taking the created at column and parsing it in a way that is compatible not only with the PySpark timestamp formatting that it expects, but also with Power BI, both of which are pretty crucial. So then we're going to drop our duplicates here, and then this is another key aspect, adding a watermark. So adding the watermark is a crucial thing with structured streaming. So it's only going to look at new data, essentially. It is not going to have to run through the entire data frame. It's basically going to look at the watermark column and only look at or process data that has been created since the last watermark was created. So we're doing 24 hours because this is a nightly job that runs every 24 hours. So we're only going to grab rows that are new in the last 24 hours. So then this is really all just going to be some ETL type stuff, some transformation logic. But the cool stuff happens here. So in this write delta table and register delta table, we're passing in a data frame and a name, and we're going to write out a delta table, and then we pass in a name and we're going to register that delta table. So if I go into my functions, let me try and get 1 second. There it goes. Sometimes that Teams overlay can be annoying. So in here, write delta table. Like I said, it takes a data frame and it takes a string. And what we're going to do, let me delete that comment. It's not going to cause any problems, but it's annoying to me. We're going to write it out with the delta format. And the path is going to be our base query path with the name appended. So it's going to go to untapped/query/ whatever the name of the table is. And we're also assigning a checkpoint location. So this is a crucial part of the Delta engine that allows auditing, rollbacks. So essentially, for every query or every transaction, we have a checkpoint that gets created. So if I wanted to roll the data warehouse table back to a certain step or stage, certain date, this is what supports features like time travel and those rollbacks. So pretty crucial. And then I'm doing this in append mode because we want to just append the new rows on the end. I'm doing a trigger of once because we don't have anything happening that would trigger this to run. We're just running it every time the nightly job runs. And then to register it, we're saying create a table with this name using Delta as the format. This could be Parquet, this could be CSV. We're using Delta, so that it uses the transaction log, all that. And then for the location, it's going to be the same location that we provided up here as our file path. And so for each of these tables, we're just doing this, this pattern of process and flatten the data, and then write it back out using, sorry, this one is fully explicit before I made it a function, using this write and register. Now, what's cool is if you look up here, where is it? Here. We have a lot of this done for us in terms of like how this should be structured, in the sense that each of the tables I'm creating are a struct within the JSON. And really, if you wanted to, you could have all of this as one huge Delta table and just use SQL or PySpark or whatever else to extract these objects from within your table, because it has rich support for that. But we're extracting each of these into their own table so that we can have our relational warehouse model. So each of these gets created in that way. Again, a write register. I guess I should point out, where is it? Yeah, so you can see underneath each one of these, the stream. Might take a second to load. Let's just look at the raw data. You can see we have 975 input rows coming in. We can see how many rows we're processing per second, what the timestamp is. You can also see down here what Watermark got created, for instance, and then how many rows were in there. And then we see there was only one new row. So that means that I had one new check-in yesterday. So pretty cool stuff. And then you can finally see where it's writing out to, like our sync. So all that's great. We also have some fact tables. So I am doing a Snowflake schema here. And so those fact tables, similarly, we're just pulling out our primary key for a particular table or struct along with the primary key across Untapped. Just creating those tables. And that's really it. That's what Silver is doing for us. This Silver notebook. So what do we do with that? I mean, it's really cool. We can go over into like our data tab and we can see that we have some tables here. You know, like if I wanted to go into brewery, I could see our schema. I could see some sample data. You know, you trust that this is a data warehouse, right? What we want to do is bring it into one of our BI tools. So over here, I've also been creating this Power BI file. So let's start by looking at the ingestion piece. Come on. Oh, come on. It really does not want to behave today. There we go. So if we look at any one of these queries, they're all brought in the same way. If I go into source, I just have this URL that's coming straight from Databricks, along with a token that I've created. If you go under your user settings, you can generate one of these tokens. I've walked through this entire process in one of my Sunday streams, so go check that out if you want more detail. And we're doing an import, and then we're essentially just selecting one of these data fields, one of these tables to bring in, and that's it. So we're connecting to this cluster that has these Delta tables as if it's a SQL Server or something else. In the future, under this new source, in addition to having the Spark source, it sounds like they are going to be adding, so if we go over to Azure, yeah, so right now I'm using Azure HD Insight Spark. It sounds like they're adding native support for Databricks that's going to support credential pass-through, all that good stuff. And I think actually I might just be using regular Spark. Yeah, regular Spark. Anyway, so that should be cool in the future, and I'll be sure and show that off. But so that's how we get our data in. And if we go over here to our model, I haven't fully finished making our model, but you can see that you know, it's a clean little dimensional model. And so like if I tried to, you know, join these two together, you can see that I can have, you know, a relationship between them. I think this needs to be deduped, which is why it hasn't been created yet. I haven't done a refresh in a minute. But yeah, you can see our nice little snowflake there. And so if we go over to our visuals, we can, for instance, see that like here, we have our fax table that's using our check-in ID along with a brewery, which is how we get our location information and, for instance, our state hierarchy. So like we can use check-in ID to get a global count. So like if I mouse over, and this might be revealing too much, but if I mouse over like Kansas City, I can see that I've had, you know, 325 beers from Kansas City. Or like if I went over to like Lee Summit, I can see, oh, sorry, that's not filtering. So I think it's 325 total. But if you wanted to do like, for instance, a click through, I could click here, and it'll filter down to just the breweries in Kansas City in that location. So you get some of those nice Power BI, BI data warehouse features that you'd expect, but it's all coming straight from a Spark cluster. And so if I wanted to, I could create, you know, some sort of new visual. Like we could do, let's see. We could do like, you know, ABV as our values, and then we could split it up, for instance, by like style. Yeah, and then maybe we'll do active as our legend or something. Yeah, I think they're all active. But so, you know, you can quickly see how you can structure this. And then if we wanted to, we could bring this in with, for instance, brewery name as another axis for, like, say, our drill down. And so I could, you know, merge these down a level. Oh, I don't know why that doesn't like it. Oh, because I haven't fixed that relationship. So the point I was going to try and show is that you can start to, as you explore this data, create some of what those gold views would be. And so if we wanted to, back over here in Databricks, we could create kind of ad hoc some gold views. And so we need to first off bring in our parameters. So I didn't explore the parameter notebook. Again, this is all stuff that's in the weekly streams. So feel free to either ask me questions or just catch up on those, but I'm not going to dive into all of it right now. But these essentially just instantiate our secrets to connect to the data lake and also bring in some of our global parameters. So now if I did a SQL magic command, I could do, you know, like, and actually I can just make this whole thing SQL. So I could do, you know, a select from like the beer table. And this in real time is querying. If we had cached it, it might be a little bit quicker. And you're going to see that over here I have my beer ID. So similarly, if we did the same thing, but against our facts table, we'll get some primary keys brought in that we could then use to join this with some other tables. So we get check-in ID and beer ID. So if we wanted to, you know, we could in real time, or not in real time, but basically in this gold zone, we could do a join between beer ID here, and then check-in ID or brewery ID, and use that to essentially bring some of these fields together, if that makes sense. And so really this is how the gold zone would work. And essentially, once you have these queries written, we can go back over here to what we did in our functions notebook. Come on. And similarly to how we did create table if not exists, you can create a view if not exists and basically instantiate it as a global or managed view within your Hive metastore. And that would make it so that your view is available in Power BI. And then if performance was a concern, you could even go ahead and cache that table out as a view, or sorry, as a table in your Delta Lake. So write it out as Parquet. And so then when Power BI is reading it, instead of having to execute that query and get it in memory, it has it already cached physically in your data lake, and then it can bring it back into the cluster memory and read it from there. But yeah, that's how data lakes and Delta Lake kind of all work together with structured streaming and some of those other semantics in reality in Databricks. So I wanna pause and take some questions because I know that this was a lot. And feel free to just unmute and speak up or drop a comment in the chat or just reach out to me later. But if there's no questions, I'm more than happy to give you guys some time back. Again, I know that this is a lot to go over in a short amount of time. All right, going once, going twice. Thanks everyone for attending today. again, just as a reminder, we are moving the Databricks live development from Saturdays to Wednesdays moving forward. That's going to be, I think, Wednesdays at noon, but there will be an announcement on LinkedIn and some of our internal blogs and all that stuff. So appreciate that. And then Lindsay will be sending out a survey about September topic ideas. That's going to be the one that's more of an office hours or Q&A. So definitely reach out. This is all recorded, so even if you're not able to attend, I would love some topic ideas, and hopefully we can answer your questions then. But have a great rest of your Tuesday, and thanks for attending.